All right, so in D, this function is defined for all real numbers, so no issues there. So when I take the derivative, I'm going to get 5. I'm going to get 1 over 5 times the fifth root of x to the fourth power as my derivative. If you're like, what sort of witchcraft is that? This is x to the 1/5, so it's 1/5 x to the -4/5 when we use our power rule, and then those two things are equal. All right, so this 5 and that 5 are going to cancel out. So my derivative is equal to 1 over the fifth root of x to the fourth power. All right, so now, all right, so our numerator is never 0. All right, so that means that it's not going to contribute any critical numbers. Our denominator is equal to 0 when x is equal to 0. So this means that our derivative is undefined when x is equal to 0. If we look at our function was defined when x was equal to 0. So what this means is that x equals 0 is a critical number. All right, so we can break our function up according to that. So 0. So that's a nice thing, right? If I just look at our derivative, we got f prime, which is 1 over the fifth root of x to the fourth power. Well, if I'm taking x and raising to the fourth power, it's always going to be a positive number. If I take the fifth root of a positive number, it's still going to be a positive number. This one on the top was a positive number. All right, so we always get positive over positive. So this means that our function is increasing. There was nothing, right? I didn't even have to throw in numbers here, right? So we're going to increase as well. It's always positive, always positive. So here's where we want to be a little careful. It's never decreasing. Its derivative is never negative, but we can't say it's increasing on all real numbers because it's not increasing at 0. It has an undefined derivative at 0. So we would have to say this for like full credit on a test or something. We're increasing from negative infinity to 0, and then again from 0 to infinity. All right, so this is that's what we're increasing. All right, so critical numbers. So we're increasing. We don't have any mins. We don't have any maxes. That's going to be, this is actually a vertical line of tangency, right? If we graph this thing, and if we just got rid of this for a second, we would have a 5. Let's see, nth root. We got a little 5 in there. We got a x in there. We got a +1 on the outside. Right, so here's a function. If we kind of zoom in, right, we can see that our function basically goes right, and then it's undefined, right? You have a vertical tangent line when x is equal to 0. So your function is basically increasing faster and faster, and then infinitely fast when x is equal to 0, and then starts decreasing again once you get to the right side of it. So there's your function.